Turn that off. Okay, let's get started with part 2. So our analysis only confirmed that what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes, or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. To figure out exactly how often each number from the left list appears in the right list, calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Here are the same example list again. Here are the same example list again. Okay, so for the example list, here is the process of finding the similarity score. The first number in the left list is 3. It appears in the right list 3 times, so the similarity score increases by 3 times 3, which is 9. Okay. Second number in the left list is 4. It appears in the right list once, so the similarity score increases 4 times 1 is 4. Third number is 2. It does not appear in the right list, so the similarity score does not increase. So we get 0. The fourth number, 1, also does not appear in the right list. Okay. Fifth number, 3, appears 3 times. 1, 2, 3. So that's 9. The last number, 3, appears in the right list 3 times. Yep, okay. So for these examples, sample list, the similarity score at the end of this process is 31. Once again, consider your left and right list. What is their similarity score? So this challenge will actually be probably way faster. Since we have the meat, we're already parsing into 2 lists. Now we have to remind ourselves that our lists are sorted coming out of this parse function. So we have a pair, the left and right list, sorted before we implement our part 2 function. So I don't think that really matters. It doesn't have any constraints that say these lists have to be in any specific order. So I don't think there's any need to alter our parse function. I think our parse function should be good enough for part 2. So I'm thinking this is going to actually be really similar to our previous setup, right? So I believe all we actually have to do is just copy and paste this here. And instead of getting the difference, we'll be multiplying them. We don't need to take the absolute value of these. So we multiply left and right. And then we're folding. And we still would add that result together, right? Yep, we're still summing the similarity score. So everything remains the same there. Other than we're just multiplying. Oh, I failed to recognize that we're not comparing index to index. So it's going to be similar, but we're going to have to map so for each value in left, we're going to have to map over to right. So that's a little more tricky. What do I want to do? I don't think map 2 will suffice. I think we want to map do we want to map or do we want to fold? Just take a peek at the list module. This might be up our alley. Both for a list are the same. Fold left 2 is actually probably what we want. The list. Fold left 2. Now we want left, right. There's our accumulator. What does this return? Alpha. Hmm. We want fold left. Could use like filter map. Hmm. to what we had here. All right. Right. Let's do this. Let count list go do this. So we'll have this count function as an accumulator. So this count function will take a accumulator and a list. I think we're going to have it take the right list. And so this will be recursive. If the list is empty, we return 0, else I think we should. Yeah, okay. So if head is equal to, it's not going to be an accumulator though. X. And X will be the value we're comparing as we map through the right list. So if the head element, the head int, is equivalent to X, then we what will we do? Well, we still have to recursively count, call count. Okay, so count fail x. So then we just do this. So if the head is equivalent to x, then we return 1. If not, it's just 0 and we move on. There. Okay. So now we're getting close. So now we can map through the left. So the count would be yeah, it started at 0. No, the count would, sorry, I keep on getting confused that the count, this x here is actually the value we're comparing as we map through right, as we map through the right list. Okay. I think that might be it. So then we do exactly what we did in part 1. We're folding the list and summing up the what's it called? The similarity score. Similarity score, yeah. So we're still summing up with this fold left. Okay. And look here again, so in our count function, we provide x, which is the current value at the mapped index we're on, and then we map through the right list. In this, we recurse through the right list. All right, I think that's worth a shot to try. No errors right now. Should give us 2. All right, so 442. Let's see if that is the right answer. That's not the right answer. Shoot. Your answer is too low. If you're stuck, blah, blah, blah. Okay, return. All right, so okay. I see what we're doing. So we're getting the count here. So what we're returning from this list map is a list of counts of each of them, each of the elements in the left list, which isn't what we want. We actually want to then multiply the count by x. I think that should do it. Let's try again. All right, so we get 24 million-ish. Let's go ahead and try that. That's the right answer. Awesome. So we have completed day 1 in Advent of Code 2024. See if there's anything else we can do or reflect on. So again, we wrote this parse function that takes in a string, just a long string. This is our long string. And then we split it up into lines. So we split by new line into lines, which we'll use down here. So we're folding. And right here, we've defined AoC, which takes in a pair list in a line. So yeah, so for each line, we're essentially recursing. No, we're not recursing, but we're calling AoC, which is going to allow us to split the line when there are spaces. So we can get our left value and our right value, A and B. We turn A and B, that are strings, into ints, and then add them to their respective list. And so then we obtain the left and right list. We sort those lists and we return that. Those are then used by each of these parts. Part 1, we just map over both the list, take the sum difference, or sorry, not the sum, the difference between x and y, take the absolute value of that. Then we go ahead and once we get a singular list here, we fold that and we sum everything together. We print it. Here again, we do something similar, but this time, to get that similarity score, we have defined this count function. And essentially, it counts and recurses through the through a list, which we're using it to recurse through the right list, and see if the value x here is in the right list and how many times it is in the right list, because each time we find a value in the right list, we add 1 to the result. So then this here returns the count of x in the right list, and we multiply that by the value of x to get that similarity score. And then so then we get a list of similarity scores. We add those similarity scores together and then print that out. And that's about it. So we didn't really implement. I need to really read up on how to use this test. It uses a external library, but I'm not really familiar with it, so I need to read up on it. What's the library called? PPX expect. So I'm not really familiar with that. So I'll read up on that. So cool. All right. So how did you guys do if you coded along? I know this was a shorter stream session, but I think we got our feet wet in the first stream, and we're able to solve this part much quicker. I think it went pretty well. Hopefully as I go along that these solutions will take less and less time. I spent some of the day getting used to this template I found on GitHub. I have the link in the description below if you're interested. Yeah, I think it went pretty good. And I hope you guys have a good day.